Okay, I'll talk a little bit about air pollution and lung cancer, but before I get to that, I was going to tell a story related to what Leo was talking about that maybe he doesn't even know. Was that one of the very first researchers, I think really the first to discover this effect of lead on intelligence in children was Herb Needleman. And he published a paper in the New England Journal of Medicine. And the thing is that what he did was he used a technique that we developed at NYU, at our labs up in Sterling Forest, the environmental medicine department. One of our students developed this technique where you would take, when children get to a certain age, like first, second grade, their baby teeth fall out. So this doctoral student figured out a way to take those baby teeth, collect them from the kids at school, and then analyze them for their lead levels. And then you could find out which kids, because your body is always storing the lead, so it stores it in your bones and in your teeth. And so these children had accumulated lead over time. And so the technique was developed at NYU, how to determine how much cumulative exposure a child had had from lead. And then Herb was smart, figured out this is a really good technique. So he went and followed kids in Philadelphia and got information about each of the children, about if they acted out in school, and he did tests like, remember that game Simple Simon, where you match the lights and the ability of the kids to reproduce red, blue, green, and how fast they could do that. And he did all these tests. And at the same time, he collected information about their teeth and found that there was a direct correlation, that the kids did worse, they were more ill-behaved and behavioral problems, and they had lower IQs and more problems in passing these tests. They didn't do as well in the tests if they had higher lead levels. So that was really one of the defining studies. Of course, for that accomplishment, he was rewarded by lots of effort by the industries to disavow his work, and they brought charges against him. And he then had his lab shut down while these NIH investigated him for like 2 years until he was, his work was validated, of course. But they had accomplished part of their goal, which was to shut down the research that they didn't like. And at the same time, other people did the same work and replicated his work. So, it moved on. But, this is the plight, I think, of a lot of environmental researchers, is that, if you're going to come up with results that the people who are making money off of that don't like, then you can expect to have a little trouble in your life. But he lived through it. Let's see if I can get this to work. Where's the view it as a, here we go. I think I got it. Okay. Yeah, I'll just briefly talk a little bit about this. I mean, there's been a lot of evidence, we know from collecting particles in the air that they're composed of different compounds. And these compounds include things like arsenic, asbestos, chromium, nickel. Now, nickel is actually one, New York City has historically been sort of the highest levels of nickel and vanadium in the United States, because we've always burned oil to heat our buildings. And most of the energy use in New York City is from heating our buildings and now cooling our buildings. These levels were very, very high. I've done studies where I've looked at the whole United States, and there's like a mountain. Back in around 2000, there was like a mountain of vanadium that you'd see if you plotted out the levels across the country from this burning of residual oil in the buildings. Now, the mayor and the administration now has banned the burning of residual fuel oil, and now we're going to much cleaner, switching over natural gas and low number 2 distillate and cleaner fuels, low sulfur. And when you take out sulfur out of fuel, you're also taking the vanadium and the nickel out, because it cleans up all the things that are linked with it. Anyway, so that's one of interest to New Yorkers, I think, historically at least. And then radionuclides from radon, which isn't too much of a problem here in the city, but up where I live, outside the city, it comes from the ground, and if you have it I'm over the Reading Prong, and that area has radon in the ground. It comes out, and if you if you happen to be getting it coming to your basement, then it can build up, and this is a lung cancer risk, especially for people who smoke. That's where the biggest risks have been. People who have radon in their home, and they also smoke. And then sort of the usual suspects, benzene, which you find a lot like in gasoline. back when I worked in a gas station, you know, we used to pump the gasoline, and so, you know, occupational exposure, surely, but now in a lot of places we pump our own gas now, right? So we can all get exposures, although now they have better nozzles that prevent the gas vapors from getting out, really to prevent ozone air pollution, but it's also reducing benzene exposures at the same time. And other, you know, organic compounds that are in particles that we breathe every day that are potentially cancer-causing. And, you know, a lot of these are also found in, you know, cigarettes, too. So there have been a lot of studies. I don't expect you to see all these, but there's, just to give you an idea, that there have been many studies where people have looked at cancer and looking at the rate ratio. A rate ratio of 1 means there's no increase. So 1.3 up here means a 30% increase in places with higher air pollution in risk of lung cancer. And there's a 90% and 80%. And some of these studies are sort of better than, considered more reliable than others. These are ecological, so it's sort of saying, well, the pollution levels are higher here, and the risk of cancer is higher here, generally. But there are a lot of other things that are different. You know, that might be a place where people are getting more occupational exposures, or the populations are different. And then there's case control, which are considered a little better studies, where you take a case where someone's got lung cancer, and then you look at someone who didn't get lung cancer and then compare their exposures. These were pretty prevalent with smoking. People, the Dahl and Hill studies, the early ones were case control. And then there's cohort studies, which are considered sort of the gold standard, where you follow populations over time and then see a cohort, a group of people, and then see, you know, which ones have which exposures and who gets the higher rate of cancer, and then you control for other variables, and that might affect that, because you have the individuals. That's the advantage of a cohort study. You're actually looking at each individual. You recruit them into it. You get information about whether they smoke and so forth. So you're able to control for that on an individual level. So these cohort studies are usually considered more reliable. So when when you're reading the paper and you want to know, you're saying, oh well, here's a new result that says coffee is bad for you. You maybe look what kind of study it was. That might help you. If it's a cohort study, you might be more reliable. But I'd say generally don't believe just one study. You have to look at lots of studies before we can draw conclusions. And unfortunately, that happens sometimes. That one study comes out and it's a lot of press coverage. Maybe Dan can talk about the paradox of journalism, where you get stories, but then you have to put it in a larger context, and in order to see that. So that's, I think, a responsibility of scientists and journalists to make sure that whole story gets out and things get put into context. Basically, Aaron Cohen's from the Health Effects Institute talked about these issues. He said, ideally, longitudinal observational studies of large populations over decades would be required. But the problem is they're very expensive. What we can hope is that we can have, if these initial studies show effects, then we can get funding to do longitudinal observations. And one such study that we've done, that I was involved in, was published in the Journal of the American Medical Association, where we followed a population starting, it was the cancer prevention study, and it was actually a study designed to figure out what causes people to get cancer. And so they collected information on diet, and I'll show you about 500,000 adult men and women. So these are people older than 30 that they recruited back in '82, and they followed them. In this paper, we've gone through '98. Now we're up to 2004. We've followed a little further. And they collected personal information about each of the individuals, their occupational exposures, so that to control that as a confounder and to find out if that was causing cancer, looking at asbestos, chemicals, solvents, coal or stone dusts, diesel engine exhaust at work, that'd be like a truck driver, and then also a general indicator of dirtiness of the place of work. Then, of course, smoking. There are like 30 smoking variables, whether, how much you smoke, how long you smoked for, and whether you get secondhand smoke exposure. Then diet, which is very important, consumption of vegetables, citrus, high-fiber grains, and so forth. Education variables, whether high school was completed, and whether advanced degrees, and marital status. Indicated for single or other or married. Having been, married myself, it makes you live longer if you're married. But for sure, it makes you, life seem longer, right? Just kidding. Just kidding. I stayed married 37 years by not making jokes like that. I should. Then also alcohol consumption had various metrics, 6 different variables for that. So after controlling for all of those variables, basically the hypothesis, and Arden Pope was the guy who really came up with the idea of doing this study. He said, well, okay, if we control for everything that the National Cancer Institute and the American Cancer Society can think of that affects cancer, and we control for all those variables, what about what's left? Does any of it correlate with air pollution exposure? And so that's basically what these plots are, is the rates of getting, this is for all-cause mortality. And you can see as the pollution levels rise, 10 micrograms, 15 micrograms, 20 micrograms average in various locations across the United States, the risk of dying goes up. And cardiopulmonary goes, and actually of these, the driving thing was the cardiac, we found in the later papers. And then here's lung cancer. So this was really one of the first prospective cohort studies that showed most definitively that lung cancer increased with increased pollution exposure. And sort of as a control, we looked at other causes that were unlikely to be affected by air pollution, and those, there was no real increase in risk. The risk stayed around, relative risk of 1. So as pollution level went up, those other things didn't go up. So that's reassuring that it's specific to outcomes that you would think air pollution could affect. So basically, as I've said, long-term exposure to, and this is fine particle air pollution, is associated with increased annual risk of mortality, and especially for lung cancer. Living in a more polluted city was associated with an approximately a 20% increase in a resident's risk of dying from lung cancer. Now, compared to smoking, if you smoke, your risk of lung cancer goes up by a factor of 20, 20 times. So that's a 2,000% increase, and we're talking 20% for air pollution. So, definitely don't smoke. But this is a comparable, the outdoor air pollution effect is basically comparable to a non-smoker living with a smoker. That's about a 20% increase in your chances of getting lung cancer as well. But the difference is with, you have a choice whether to live with somebody who's a smoker or not, whereas you have no choice but to breathe the air. You can carry around your water or you can choose your food, but pretty much we're all breathing the same air, So that's something you really can't control on an individual level. And I think that, again, goes back to what Dan was talking about, is that collective action sometimes is required to really influence our environmental exposures. One of the areas that people have done a lot of research in terms of cancer and air pollution is diesel, and I alluded to that. And there's a host of studies, a lot of them animal studies, where they exposed to carcinogens and found higher rates of cancer. So this, the World Health Organization, the California EPA has concluded that the rat data have demonstrated carcinogenicity of diesel exhaust particles and designated diesel particulate matter a toxic air contaminant. So the EPA in 2002 said diesel emissions are considered likely to be carcinogenic to humans. So that's one component that people, especially diesel particulate matter, are a risk. And one of the things that supports that is a study that was done, Eric Garshik up in Boston did, looking at trucking workers. So again, you're looking at occupational exposures and their risks. And the trucking industry workers that have regular exposure to vehicle exhaust have an elevated risk of lung cancer with increasing years of work. So that's consistent with what we're seeing in the ambient air pollution, that workers are getting increased risk. And then, what about New York City? And we've looked in the past, we've done studies in New York City, and we've looked at the concentrations of particulate matter, and you can see that basically, you know, we get the highest levels in the urban area where there's the most traffic. And so that's one of the New York City's, I mean, we get a lot of pollution, especially in the summertime, from outside the city, but then on top of that, we have the local traffic emissions. And especially, I think it'll become more dominant now that we're cleaning up the wintertime residual oil combustion by heating in apartment buildings. We're going to see that traffic is really going to become a major component of the risk in living in cities like New York City. And, you know, diesels cause most of that particulate matter. Cars put out a lot less particles than do diesel. This is monitoring over time a road where there's primarily trucks, and you can see the levels are quite high. Remember, I was talking about 10 and 20 micrograms. Well, here you're talking 60, 80, 100 micrograms. And then in roads that are limited to automobiles, much lower levels. And also the composition is different. The diesel soot is different from the particles that come from cars. Here's some monitoring that we did in New York City a number of years back, where we rode inside of diesel-powered buses with monitors. And we looked at ultrafine, we looked at ultrafine particles and black carbon. This is the black carbon soot that we measured. And so inside of a conventional diesel bus, so it's not just the, you know, when you're behind a diesel bus and the emissions. If you're inside a bus that is using diesel, you get higher exposures. So it's like a little exposure chamber when you're riding in a diesel bus. Not very reassuring, and you're paying money for it too. But then we went on the newer diesel buses, the hybrid diesel buses that they have some in New York City, and I think they're getting more. And the levels were much, much lower on those vehicles. So they were newer vehicles, and they were using this hybrid technology where they're running on electricity a lot of the times. Like when they're idling, they're on electricity, and they're not burning the diesel when they're idling. Another thing, aspect of this I thought you might be interested in is the whole question of the diesel trucks from getting rid of waste, and the fact that you know, there's been a plan that, well, you know, Mayor Bloomberg came out with a plan in 2006 to come up with ways of getting trash out of New York City without using so many trucks and having local transfer stations. And he hasn't, and you know, using waterways. So he's going to have water transfer stations and then take it away by waterways. So we wouldn't have all these miles of diesel trucks picking up trash. But, you know, he wasn't successful. Of course, prior mayors have tried to do the same thing, so you can't blame him too much. This is a very difficult thing, but he hasn't been successful. Of all his other successes, this is one we still have this problem, and it's been estimated that if they could actually implement that plan, where they would bring the trash to water transfer stations, you could reduce the truck-related traffic by more than 3 million miles per year. So you could really lower these exposures that we're getting from diesel trucks, right, by doing a better job getting our trash out. I mean, personally, I think, you know, New York is surrounded by water, and we just don't use it. You know, we've got Hunts Point, where we've got, you know, the flower market's there, and the fish market moved there, and the flower market's there, and it's, you know, Hunt Point is surrounded by water, and they could bring things in by water, but no. What they do instead is they drive trucks, diesel trucks in there, drop off the things, and then people come in and pick them up and drive back out. It's all through residential neighborhoods. I mean, it's really, and it seems obvious to me, you know, New York is sort of like the Venice of America. We've got water all around, and we could be using it to transport trash and transport goods and reduce the amount of traffic around the city. So, you know, something to think about. And, you know, the routes, the truck routes that people take, actually, most of the trucks that carry goods into Manhattan go through the Bronx first. So the Bronx is really the doorway to Manhattan for most of these goods on these diesel trucks, or some people would say the doormat of New York City, because there's all of these traffic. And we've done studies in the South Bronx of kids and asthma. Did a backpack study you may have read about back in the early 2000s, where we looked and found that the kids who got more exposure to diesel pollution had more asthma problems. and there was an editorial in the Times about it. And then that was about the time when we started to get some of these regulations. I think it was helpful in getting these regulations about idling by schools and things like that. So some measures have been taken as a result of, I think, some of that scientific research we've done. So overall, you know, urban air pollution is a global health risk, and I didn't get into this recent study that we've done globally, estimating exposures to particulate matter and the health effects that come from those. But it's not unique to New York City, this problem, that's for sure. And you know, if you travel around the world, you realize people are driving more and more. It used to be, when you went to China, everybody was riding around on bicycles. Well, no more. They're all in cars and stuck in traffic. So it's a worldwide problem. I think developing worlds should try and learn from our mistakes, but they seem to be repeating many of them, unfortunately. And so fossil fuel combustion sources, really, when you look at, you know, in terms of air pollution, what the problem is, it's fossil fuel combustion. And in urban areas, especially diesel soot. And so to address this problem, we'll need to focus on optimizing interactions of urban energy and planning choices with respect to their environmental consequences to try and minimize these risks, such as dealing, you know, with our trash collection and truck traffic through the city. Okay, well, thank you.